Okay, so two things. I want to make sure that you understand why the rules work the way they do. And I want you to feel comfortable when to break the rules and what to tell me. Right? So one rule is when you're multiplying, what do you have to do? If I had like 0.09 times 411. Beautiful. So you can estimate this to be what? 0.10 or 0.1. So that went up. So you want this to go down. And you take it down to the next whole number down. Right? So try to make them as whole as you can. And of course 0.1 times 400 is 40. You just have to take that back once, right? Because 0.1 is really 1/10. When you divide by 10, it just takes the decimal back one place, right? So that just comes out to be 40. You can always double check in your calculator, just actually do the true multiplication and make sure you got close. Cool. So this one you don't have to say a word. You didn't break the rule. If one goes up, the other one's got to go down when you're multiplying, which only makes sense. That would keep the balance. When you divide, what's got to happen? Multiply. One up, other down. Divide. Both go same way. Cool. So if I had, for example, what do you have, John? I don't know. I got 8,892.14 divided by 440. Yeah, sure. 6.1. Let's see what you guys think about this. Now, if you take this one down, you got to take this one down, right? So that's one way you can do it. If you take this down, you want to take it down to what? 8,800. I love it. So if you take that one down, you got to take this one down a little bit. And now we go to 440 maybe. And you guys see now those kind of act with each other good. 44 goes into 88 very easily, right? A 0 cancels.
Why didn't you just take it down to 8,000?
Because this is what I had for a suggestion. Then we can do 8,000 next. Sure. 44 goes into 88 twice, so you get 20. Right? And I went the same way on both, so that's fine. And again, another piece of this estimation section is there's not one right way to approach it. Right? There's one correct answer, but there are several correct estimations for the answer. So I didn't have to do this. I could also go all the way down to 8,000. And then I would take this all the way down to 400. And then still get 20. Right? Or you can take this up to 9,000 and take this up to 450, and that's still 20. Because 90 divided by 45 is 2 still, right? I mean, that's, you sort of should end up the same, around the same number at the end, no matter what you do, really. Okay, maybe. If you break the rule, that's when you tell me, you know, for here, if I would have taken them both up, that would have been a high estimate. Both down, that would have been a low. It's very simple with multiplication. With division, if I take the top one down and the bottom one up, I'm dividing less by more. That's less. It's a low estimate, and the other way around. Right? So if you break the rule, you got to tell me what you get in the end. Okay. So the important thing to get from section 1-2 is there are two main rules you want to try to adhere to. You know what to do if you want to break the rules, and beyond that, show me your work. Because there's a ton of different ways to estimate things. We each have our own way. Anybody waitress or waiter out there currently or in the previous year? Not too long ago. Do you have a certain way? I know nowadays it says on the bottom, like I said last time, it actually lists 15%, 20%. Does it do that where you work? Or do you have a way you can tell in your head real quick? I mean, right now, what is it when you look at a bill? It's like 80 bucks. Do you know what to expect for a good tip? Do you know
well,
what to feel?
I do now once we did the 15%.
So you didn't really have a way before that?
I would just find out at the end of the night if I got good tips.
Oh, that sucks. Did you have a way?
I mean, not really. I just kind of, I guess I just did it so many times and I kind of figured it out. Like I always double the sales tax. Yeah. And then I
there you go.
That's like
because the sales tax in California is 8.5%, right? So if you double that, that's like 17%. That's beautiful. That's kind of like what we did, sort of. We're playing with the percentages to put them together to make what we want. So that gives you a good, feel for a decent tip. So more than that, you're happy. Less than that, you're like, what did I do? Yeah. Okay, cool. How do you guys feel about 1, 2? I mean, that's decent. Okay, I really want you to understand that if you have a certain way you do things, do it that way. Just show me what you're doing.
I
Yeah.
had a couple questions from the homework.
Okay.
32 and 48.
Section 1, 2.
Yeah.
All right, so 32 is the one that's from San Diego. I love the picture there, really. I know La Jolla was so close to Ocean Beach, but they give you that track, and then they give you, at the very bottom, the mileage, right? So when you do your homework for this, tell me how you did this. Personally, what I normally would do is take a piece of paper, mark off 1, 2, 3, 4, 5, and then just kind of put it up against the red piece. I think it's just the red piece they want, right?
Yeah.
Hazard Center to Old Town.
Couldn't you can count the slashes there, right?
Do the slashes match up directly with
I would assume so.
mileage? It's a big assumption to make, so they don't say it. So you gotta be careful. Or you can just put your you could put your pinky there. My pinky nail is just about 5 miles. So then 5, 10, 15, right? So just tell me. Don't give me a number. Give me the number and say I used my pinky nail. I used the edge of paper. I used a ruler. Right? Cool. Because there's later problems where they say how many of these figures fit in this shape.
Right.
Then I would use my pencil eraser, which almost the same size as that thing was, or a little piece of paper and you just move it around. Whatever you have to do, tell me what you did. Right? I cut the piece of paper out of my book. Hopefully I didn't do that. Okay.
And then 48.
Oh, 48, I like. It's the one that's got the grids, and on top of that is the circle.
Right.
And they want to know how much of this is shaded in. So I think there's 4 in the middle that are definitely shaded in. Yeah, exactly.
And there's 4 on the outside.
We have to look at the ones that are like half million.
Say again? Yeah, exactly. You want to kind of take that into account too. So they have a circle, sort of like this,
Shaded.
really roughly. So it's definitely got 1, 2, 3, 4, and these are almost shaded in.
So do you want the half shaded ones or the ones that have any shading in them?
Yeah. So if these are almost shaded in, like these would fill those in, right? Even easier, these would fill these in just about. So you get 2, 4, 6, right, and then 8. And then you can keep going from there. These are almost full, these are almost full, so altogether maybe 2 or 3 from those. You guys, so you want to fill in, that's a little bit, that would actually fill this in. So then you get like a whole square there, right? Just give me an estimate and say whatever way you approached it. Now you could sometimes, I think like number 47 is easier because you can just kind of mentally shift that whole thing down and then it just fits perfectly over some squares. You can sort of do the same, move this over a little bit, and you have 1, 2, 3, 4, 5, 6 that you capture perfectly, but then you have to think about what happens on the top and the bottom. Think about that, right? So 1.2, this whole class, some of you guys are not going to like the idea behind this class. And I can see on some of your faces you already know and you don't like it. It's creativity and math together, right? And there's a lot of creativity in mathematics, not just with visual things, just how to use mathematics itself. So that's why it's so important you tell me what you're doing. Because a lot of times I never even thought to do it the way you did it. And I'm like, that's freaking cool. I never even thought about doing it that way. And then I start teaching it that way. Because I like it. That's a lot of the stuff I teach in algebra, I learned from my students. The way they kind of did things. I just did this because it helped me out. I'm like, cool, now I teach difference of cubes based on what somebody did on their homework. I'm like, I like that. I do it that way. Right? Yeah.
There was one on that also page 14, and it was something about estimating. And I was wondering, for problems that you add multiple numbers, would you like bring down 1 and then?
Yes. When you're adding, it's like multiplying, right? To make one go up, you want to make something else go down by about that much.
So if there's like 5 numbers to add together,
Number
just
15.
do one, not the other, and then go.
Like number 15?
Yes.
Yeah. So I take the 4, down, the 279 up. Right, if you end up making more go up than go down, then it might be a high estimate. But as long as you're trying to keep the balance, if you take a few up, make sure a few go down. You're trying to get a quick estimate. And normally for cost, do you think I normally want a high estimate or a low estimate? High, you want to be conservative. You want to expect to have to spend more money and then be happy when you didn't have to spend as much. But you want to bring enough with you. Yeah?
Well, about an example like number 30 where you're adding 5 numbers and then multiplying it by another number, would you just
Bless you.
round the addition, or would you just do
I would do the addition first because there's 1, 2, 3 numbers that are related to costs over 6 days,
Right.
So add them all up. You estimate the addition.
Right, okay.
Then you can estimate the multiplication with 6. And then the 973, I would just make that.
So you're going to estimate each number, like 973 would go up to 1.
So what is it you have to do for that problem? You got 973 for the flight.
That's fast.
And then you got 6 days where you have to pay like 3 different costs each day, right?
Yeah.
So in here I would do this like we just said, take one up, take the other one down.
Okay, yeah.
Then you can estimate this 6 times whatever. And now you can probably just do directly, like get 90 in there, that's 540, that's nice. And then plus 1,000, I'd say, take it up.
Yeah.
But this is important. If you write for yourself what you would do with the numbers they give you, then on the one below it, say approximately, and now start approximating everything, it's easier for you to do and easier for me to grade. Because then I see where you started and what you estimated.
All right.
Yeah. Any other questions from? Yeah.
I have a question from 1.1. Can you use 30 because I didn't understand it.
I love 30. So this is the, and normally that doesn't really, when I say I love a problem, it doesn't really translate. Normally students are like scared of that problem. The description of this problem is a little bit weird. So they want you to select from 1 to 99, select a few single and double digit numbers. Right, so I'll pick 8, 37, and 66. Sure. Right? So I got some evens, I got an odd one in there. You want to make a mixture kind of problems, numbers, so you don't see the wrong pattern. Now if you multiply, and this is multiply each of those by 9. So there you get 72. There you get, let me see my brain's 273. No, 333. And there you get 540, 594. Okay. So that's the first step, or the first couple steps, right? A, select some stuff, multiply each by 9. Find the sum of the digits in each of your products. So 7 plus 2. So part B says 7 plus 2 is 9. 3 plus 3 plus 3 is 9. 5 plus 9 plus 4 is 18, but then 1 plus 8 is 9. So keep adding the digits until you get to 1 digit. That 1 digit will always be 9. Cool. So that's, I understand, because everybody had, the way that they worded the directions, I think, is a little weird. That's what they mean.
Okay.
So maybe now use your own numbers there. It doesn't only work from 1 to 99, it works from 1 to infinity. Anything you pick, anything divisible by 9, the digits must add up to be 9. We take them all to a single digit. That's nifty. Cool. Yeah.
I have a problem with number 13 on 1.1.
Oh, and that's another nifty one. That's now a real quick thing. Something you have to deal with me about. I'm going to try.